All right. Now we're cooking.
Jesus? I look for the house of death.
The souls of the undead.
Yep, exactly.
Unity decided to download again. It must have been on the download page and it refreshed. Well, hopefully Adam starts up in a moment. Get Keynote open. Adam seems to be struggling too. What is going on? Let's kill Adam. Restart Adam.
There you go.
Okay, and then this is us, right? All right, so make roll work with our new formula thing. So our formula is we have a number of dice followed by a D. Does somebody want to hit the third button down? Please, thank you. So we have a number of dice followed by a D followed by the number of sides for the dice. So in this particular case, we are rolling 203 20-sided dice for our roll.
Pretty big attack roll.
Well, yeah, it's true. Okay. All right, so we want to change the definition of dice to support this. A couple of ways we can do this. What I'm going to do is, since we might want to roll this multiple times, and we want to kind of make this feel realistic, right? Because, you know, if you've ever played, how many of you in here have ever played like a tabletop role-playing game like D&D or something like that? We have 1.5 people who've ever played this.
This is something we should fix.
Yeah. We're gonna have like a D&D day because so when you get to like high level Dungeons and Dragons, okay, and this is what I'm getting at with this example. Shut up! This is what I'm getting at with this example is, if you're like a wizard and you're going to do a fireball and you have to do like 30 D6 or something like that, you don't roll a single D6 30 times. Okay? You bring out your collection of D6s. Boom! And then you have to go find them under couches and stuff like that. That's a thing. But we're going to have if we're going to do 208 something, we're going to create a list holding 208 dices, something like that. Okay, that makes sense. So, or possibility for rolls. So we're going to individually roll it that many times. All right. So we have now number of dice and we have number of sides. We're going to read in our formula. So I've already started writing some of this. So we're going to start off the beginning, potentially go all the way to the end. We are looking for a D. As long as we are not currently looking at a D, we are going to build up number of dice to be our roll formula. Okay? Otherwise, or our number of dice to be the next position in our roll formula. So in our example down here, we'd hit the 2. We'd say, is that a D? No. Collect it. Hit the 0. Is that a D? No. Collect it. Hit the 3. Is that a D? No. Collect it. Hit the D. Is that a D? Yes. Add 1 to my pause to move me past that and break out of the loop. So I should have in number of dice the value 203. Similarly, we need to have another while loop then, because now we want to go from pause all the way up to the length of roll formula, the rest of it. We kind of knew when we wrote this Boolean expression up here that we weren't going to go all the way to the end, right? We knew we were going to bump into a D before then. Mm-hmm. All right. And that's when we broke out of that loop. Well, now we want to go all the way to the end and collect the rest of, this is the number of sides. Okay? So we'll have while pause is less than the length of roll formula. We will say number of sides is equal to number of sides concatenated with roll formula at bucket pause, and then pause plus equals 1. So we'll add 1 to pause. Go ahead.
Is that already on the bottom of that?
Do I already have that down there? Well, I do have that down there. Well, so we repeated that. So what were you, so I already gave you all that code?
Yeah.
Yeah,
This assignment should have been trivial.
it was.
All right, so we already collected that. We already printed it out, proving that we already have both of those things. So we should have, from this example, our 203 and our 20, right? But we have those guys as strings. Okay, I need to get them as numbers so that I can, do something number of dice times. And what do I want to do? I want to roll the dice each time. Okay, so I'm going to go ahead and I want to update my number of dice and my number of sides to be the integer version of those values. So I'm going to say number of dice is equal to int number of dice. Number of sides is equal to int number of sides. Like that. Okay, so that will convert those two strings that we built up into the integer versions of those. All right, and it's nice that we're dealing with a loosely typed language because just a second ago, number of dice used to hold a string. Now it holds an int. All right, but it represents the same value. So that might be a little perk of a loosely typed language, is that we can just switch types on the fly like that.
In a strongly typed language, would you have to use a completely different variable?
You'd have to
or-
create another variable of the new type. So we would have had up here, we would have had string number of dice, string number of sides. Then down here, we would have, maybe we would have created two more variables up here for like, although actually we're not done here yet. So because of the way I originally wrote this, so these guys are local variables. They don't belong to the class itself. So if I would have said self dot this and self dot that, then we could do that. Yeah, let's actually do that. So this will create the variables owned by the dice object. And then down here, I can say self dot and self dot to switch types. So when I say self dot, that means this is the variable number of dice that is owned by this instance of the dice class. All right, and hopefully it'll let me switch types inside of an object. It's loosely typed, it should let me do that. All right, so they start off as strings, we fill those strings, then we convert the two strings to the integer versions of them. All right, so now we have the correct number of dice and the correct number of sides inside of roll, instead of just rolling our thing one time. So we are rolling from 1 to self number of sides. That's the dice we're now rolling, right? But we're doing it some number of times. So for I in range from 0 to self dot number of dice, we're going to do something. What are we going to do? We're going to roll the dice and add it to a sum. So I'm going to create a sum here. Starts off at 0. The first time we roll our dice, we'll say sum plus equals whatever we roll. We'll do that number of dice times, ultimately adding up values inside of sum, finally returning sum. So roll should now roll our number of sided die, number of dice times, summing up all the rolls, and then spitting out the result. So then down here, we can go ahead and say print d20 dot, oh, that's weird, d20 dot roll. Save that. And we should get a big number, some number between 203 and 203 times 20, 4,060. Some number in that range. I think it's really unlikely that we're going to roll 203 straight ones. But technically, it could happen. That's the day you buy that lottery ticket. Or you're using, wasn't he our dice maker? You're using his loaded dice. It's just really heavily weighted. Or all the sides are ones. One of those.
That's how you do it.
One of those two things. Okay, so let's go run this guy. Python 3. Is it desktop? You guys keep moving this on me, don't you?
Yep.
Oh, hold on. I'm building it in here without the self dot. These guys here, I needed to update these to self dot as well.
You could also have the local variable for all of them and assign self dot at the end.
Yeah, but why would I want to do that?
Type it less. I don't know.
Well, then you have two variables.
I mean, you can assign self dot equals integer cast of the regular one.
I understand, but then I have two variables. I'll have a local variable.
Yeah.
I'm just wasting memory.
Memory.
Might as well be eating peanut butter pancakes.
It was worth it though.
Not on my diet. I only get 2,800 calories a day. Your 2 a.m. snack was probably 4,000. Just destroy me.
Yeah, it's still.
Go ahead, you did fast have the humor pancakes. Oh my goodness.
Those supposed to be pretty good pancakes.
Those,
You know, it's the best pancakes around. Solly's Grill. Yeah, actually, they're the home of the Butter Burger. If you've never been to Solly's Grill, it's just south of Bayshore. You have to go there.
is it SOL?
No, Culver's is not a Butter Burger. Yeah, Solley. Yeah, if you go to Solly's, you will understand that Culver's is not a Butter Burger. I like Culver's as well as the next guy. At Solly's, after they cook your burger in butter, they take the bun and they slap butter on it. They don't just gently. I mean, they put 2 tablespoons of butter, and they put and then it just melts all over it. And then stewed onions. Oh, it's just so good. Yeah, but from a pancake, so they're you got to go there for a butter burger. But their pancakes, they have Door County cherry pancakes, legit.
How close is that restaurant going to be?
It's 20 minutes.
Well, the restaurant is 20 minutes, 15 minutes south of here, and the hackathon is north.
Is it worth?
Oh, it's a life-changing experience. Okay, so now I've updated my self dots in here, so we think should be good to go. So there's my 2-1-1-1. Sounds pretty accurate. If I roll those dice again, 2-2-7-4, blah 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 blah. Now, we might be interested in knowing the individual rolls, right? So maybe we go ahead and give this guy a list that has maybe in bucket, maybe the last bucket of the list has the sum of all the values, and all the values leading up to that are the individual rolls, something like that. All right. So, because I'm rolling something 203 times, I might want to know what those 203 rolls are. And then I might be interested in also the total sum, so we can tack that on to the end of the list. Okay? So, we'll go ahead, we'll give ourselves a call this guy a list of roles. This will start off as the empty list. Each time through, we want to go ahead and store the current role. So we need to know what we just rolled. Because I'm going to use that value twice. I'm going to use it once to add on to sum, but I'm going to use it another time to throw it into my list. So we'll say sum plus equals roll. So add on to our running total, whatever we just rolled. Then list of rolls dot append roll, the roll we just rolled. Then in the end, instead of returning sum, we'll do one final append, list of rolls dot append, and we'll append our sum. So the very last bucket of that list will be our total for all the rolls. And then we'll go ahead and return list of rolls. That makes sense? So now instead of just having this just blob number, now I'm saying here is the 203 individual rolls, and here's what they all add up to, in case you want to know that. Go ahead and run that guy. So there's our individual rolls. And there's the sum of all those guys. What's wrong with this approach to this? I mean, this might be something we're interested in. I mean, we might be interested in the individual roles. We might also be interested in the total sum. We stored it inside this list. What's wrong with using a list for this purpose? It's the weakness of this. Go ahead.
Takes up a lot of memory.
No, not a memory thing. It's more of a kind of correct problem-solving approach. What's wrong with this problem-solving approach?
It takes a little too long, or is it ineffective?
Didn't it feel pretty instantaneous?
Well, to get there.
Go ahead.
Isn't it kind of just like a blob of numbers, like it's not organized?
Okay, tell me more about that.
Like we could go back to our like previous assignment where we sorted it into like a dictionary or something like that, so we can see how many times the number was rolled, I guess. So it's not just a blob of numbers, I guess.
Let's say that I didn't explain what this program does at first, and this was the output. Does that really have any semantic meaning to you?
No.
Hey, this is just a pile of numbers. And that last guy looks a lot bigger than the other ones. I wonder what he means. Make sense? Now, if we're the one writing this and we're the only one using this, and this is for a temporary solution, we're just kind of doing some math or something like that with this, then maybe this is fine. It's like, we'll just throw our sum in the last bucket. We'll just know that's where it lives. It lives at the length of the list minus 1. That's where our sum is. Make sense? Okay. What would be a better solution for this?
You can print out different things. You can like print, and then you could say list of roles, and then you can print out the solution.
What would be the better object-oriented solution to this? Let's say I wanted to create another object to store my result. So right now I have this idea called a role class, right? Okay, where a role class kind of represents a single dice. Now, when we're sitting there, I mentioned earlier we had the wizard, right? Get ready to drop the giant fireball.
Mm-hmm.
He pulls out from the bag his collection of dice, okay, and just dumps them on the table, and that's his roll, okay. I'll tell you what, 2 a.m. at Denny's, that thing has an effect. It has an impact on the rest of your day. Okay, somebody's dropping a 203 D20 fireball. I mean, everybody's dead. That's going to kill everybody. Because usually fireballs are like D6s, and it might be like, a powerful one might be like 8.
Really?
Yeah. 203 D20s is.
That's a nuclear.
Yeah, that is a nuclear explosion. Yeah, it's bad.
Game board's gone.
It's bad. Okay, but the point is that person, if we're thinking about the point of object-oriented programming, is to allow us to approach problems in a similar way to how we solve them in real life. that person who's playing that wizard, they reach into their probably little bag that has all their dice in it. They pull out the collection of dice. So inside their in their hands here, they're holding 203 individual d20s, right? Okay. And then they're going to roll those 203 individual d20s. And after they roll that, then they're going to go through and count everything up. So couldn't we create an object maybe called a roll collection? And a roll collection maybe has associated with it a list of the most recent rolls, as well as the sum of the most recent roll. It maybe has a function that does the magical roll with however many rolls you want, however many sides you want. And then we revert roll, or our dice object, back to what it used to be. Because a dice is a dice, right? This guy has 6 sides, I roll it. I needed to roll 203 of them. I picked up 203 of those dudes and rolled 203 dice. That makes sense? So what we have now works. Okay, this accomplished the task. But we really could use a second object here. So maybe we say we're going to have a class called dice collection. All right, and this guy's going to be a collection of dice. So we'll go ahead and define this guy. He's going to take in a self, and he'll take in a number of dice and a number of sides. Now, we actually could approach this a little bit differently. Instead of letting this guy do that logic, we can say that this guy actually takes no parameters. And maybe what he does is he says self.dice is an empty list. Self.recent rolls is an empty list. Self.recent sum is 0. All right, so when that guy who's playing the wizard, when he, before he went to the geek store to buy all of his dice, he maybe has like a Meyer bag or something like that. It's like, I'm going to keep all my dice in here, right? Usually it's not a Meyer bag. Usually they have something with like a old 8-bit video game on it, or something nerdy, right? Okay, but that's where they're going to keep their dice. That's their dice collection. But when they first take out that bag, that's an empty bag. There's nothing in there, right? It's just ready for me to throw dice into it. Okay. So he goes out and buys a D20, brings it home, throws the D20 in his bag. I got one of those, okay? And over time he collects them and that kind of stuff. So it started off as being empty. Then we have to have the ability to add a dice. We'll call this guy a dice. And what will this guy do? We'll say self.dice.append a dice. So we're going to go ahead. We just went to the store, came back. Somebody built me a dice, probably this guy. Okay, and I'm going to throw it into my dice collection. I'm going to add a dice to my dice collection. Make sense? Where do I put that dice? I put it in my my list of dice that this guy manages. All right. Then I need to have the ability to roll my dice. All right. I'll have my ability to roll my dice. And what this is going to do is it's going to go through each dice that lives in this list. How many dice are in that list?
However we have.
How many dice are in this list?
0 right now.
How many dice are in this list?
0.
You just answered that. It was wrong the first time.
All of them?
If I were to write a line of code, how many dice are in this list? What line of code would I write?
How many dice are in this list?
The length.
Length of self dot
Okay.
dice. So for I in range 0 to length of self dot dice. That will always be the current number of dice that live in that list.
Yeah.
Okay? And what am I going to do each time? I'm going to roll it. So we're going to go ahead and we're going to say our, we'll say self dot recent sum starts off at 0. We want to go ahead and do self dot recent rolls. Does probably don't need to empty it. We just need to refill it. Is there a built-in function to remove all elements from a list? There probably is. It's like a remove all. Python 3 remove all elements from list. Delete all objects in list.
Oh, clear.
So what is it clear? Yep, my list clear. All right, so we'll say self dot recent rolls dot clear, and that will empty it out, assuming there was ever anything in there. Okay. Then we want to go ahead and fill that guy back up with rolls. So we'll say roll is equal to self dot dice at bucket I dot roll. What will be found at self dot dice at bucket I? What lives there? Go ahead.
The number between 0 and the length of the self-dot dice.
What lives there can produce one of those guys. Actually, let's assume you said something a little bit better than that. We'll say that a guy that could produce that type of thing. But what actually lives in that little memory space? Go ahead.
Instantiated object of the dice class?
Yeah, a dice. Right? This guy's going to be a collection of dice. So when I go to bucket I have that guy, and I pull out a dice. When I roll that dice, he gives me a number between 1 and the number of sides for that dice. Make sense? So this guy right here is an individual, an instance of our dice class. And I'm then going to use that instance and ask him to roll himself. I will store the roll inside of a variable called roll. Then I'll say sum plus equals roll. You add it on to my, actually it's not sum, it's self.recent sum is what I've called it here. Self.recent sum. We'll add that to our roll. Remember we zeroed it out here. And then we'll say self.recent rolls dot append roll. So that's what it means to roll a dice collection. You reach into your bag of dice, you pull out the number of dice you want to roll, and then you roll them. You add them all up, that's your recent sum. You look at the individual ones, that's your recent rolls. Make sense? And now this guy is going to work in conjunction with our dice object. So our dice object, instead of taking a roll formula, well, he'll still take a roll formula, but he's actually, who will take a roll formula? This guy will take our roll formula. So let's do this. We're going to move our roll formula into our dice collection, because we're going to have him figure out how many dice he needs, and we'll come back to that here in a second. Actually, let's just steal. I'm going to doctor this here in a second. Steal all this code. We'll bring this up into our dice collection. And we're going to move these back to just local variables, because we're figuring out the number of dice and the number of sides, and then we'll actually physically create those dice objects and load them into our dice. So same logic we had before to figure out how many dice and how many sides each of them have. Okay. So now we have all those numbers. So now what we need to do is we actually need to go and create instances of dice and stick them into self.dice. So for I in range from 0 to number of dice, what are we going to do? We're going to say self.dice.append. And what are we going to put in there? We're going to put in a dice made with number of sides. All right, so this guy will get filled up with a number of sides. Now we need to go and fix our dice object, revert it back to what we had last time, right? Where we build an individual dice, he just has a number of sides and he rolls a value between 1 and that number of sides. So down here in dice, this guy will take in a number of sides, and we'll set self.number of sides equal to number of sides. Then down here when we roll, we'll go ahead and return a random number between 1 and self.number of sides, rolling a single dice a single time. All right? That's what a dice is. You go to the shop, you buy a dice, that dice has some number of sides, you roll it, it gives you a number between 1 and that number of sides. A dice collection takes in a roll formula. It starts us off with some empty things here, and then it goes through and it extracts how many dice and how many sides they should have from that, like we did before. And then it goes ahead and it creates a whole bunch of instances of dice objects. So if I'm creating, in this case, I created 203 D20s, it'll create a D20, then another D20, then another D20, 203 times, putting each of those individual D20s inside of this collection of dice, this list of dice. So at this point, my dice collection now holds a variable called self.dice, which is the equivalent to my Pac-Man bag filled with dice. Okay, it's my dice collection. When actually we have an add dice thing for this, so we could actually do this. If we want to use our own function, we could say self.add dice. What dice are we adding? We're adding that dice we just created. And what does self.add dice do? It just appends it to our list of dice. Either one of those would have been acceptable. You can decide whether you want to externally write the function and call it from within here, or you just wanted to do the logic directly in here. Having this external function allows you to then tack on additional dice to your list if you want. What was your question?
Looking at the roll function we made.
This one down here?
Yes, we're calling roll within it. Is that why do we want
Well,
that?
this is dice collections roll.
Mm-hmm.
This is an individual instance of dice roll.
Okay, so that's
They have the same name, but they belong to
it's
different
functional
people.
from the other class.
Yeah.
Okay.
Yeah. So if somebody tells me to wave, you don't start waving too, right? They would have to tell you to wave. Okay, so this is our dice object's roll method. So it just happens to be a method that has the identical name.
Okay.
But it belongs to a different dude.
Okay.
In fact, a different kind of dude. Not even another dice collection. We have dice and we have dice collections. When a dice collection rolls, he rolls all of his individual dice. How do we roll a dice? By calling that individual dice's roll function.
Okay.
All right? So when we roll our dice, we're going to go through and we will zero out recent sum, clear our recent rolls because we're interested in those recent rolls, then go through and roll all of our dice, telling each dice to roll itself, store the roll in this variable called roll, tack it onto our sum, tack it onto our list of recent rolls. So then down here with our formula, we can have our dice collection is equal to our dice collection object passing it the formula. Then we can say dice collection dot roll. Then we can say print out dice collection dot recent sum, and we can print dice collection dot recent rolls, and that'll show us the recent sum and the recent rolls. There's the recent sum. There's our recent rolls.
Okay.
That makes some sense? Now, if you're really playing Dungeons and Dragons, though, sometimes you get to throw out your worst some number of rolls. That make sense?
How does that work? Do you mean like you get to roll extra dice? You take the best 5?
Yeah. So maybe So maybe you have to roll. You roll 7d6, and you only keep your best 5. So that means you're throwing out your worst 2.
Okay.
Something like that. So we want to be able to, and by we I mean you over the weekend, want to be able to write a function for a dice collection called remove worst and this guy will take in the number of rolls to remove. If you want to drop your worst 2, you would pass in a 2. If you want to drop your worst 8, you would pass in an 8. Okay? And what this guy should do is it should modify the contents of what do we call it? Recent rolls and recent sum.
Mm-hmm.
Recent rolls and recent sum such that they now represent the amended sum and rolls associated with removing number of rolls to remove number of rolls from the collection. That make sense? Okay.
Are you gonna put this code up on Slack?
Oh, of course not. I'll give you this code as a starting point. How do we remove something from a list? How do we remove one element from a list? Don't we say remove and then give it the position we want to remove?
Or you can do pop.
Pop, oh yeah, it is pop. Pop at a position, right? We have 2 versions of pop in our toolbox.
Mm-hmm.
So look back at the slides to see our version of pop. Go ahead. Can you give an example? So if my collection was, if when I printed out recent rolls, I had rolled a 2, a 4, a 5, a 1, and an 8. And then I wanted to remove worst 2. It should update those internal variables. The worst 2 rolls there is the 1 and the 2. So I should now have a 4, a 5, and an 8. And my sum would be, was that 17? Instead of a 20. So after I had my collection of dice, if I say remove the worst 2, I'm going to go through all of those rolls. I'm going to find the worst 2 in here, get them out of the list, so that's going to produce a new list that's shorter, and then recalculate my sum, showing me a smaller number because I've taken the 2 worst values out. Make sense? So I'll leave those in comments down here. Questions, comments, concerns, bribes? Hey, remember, those of you who are doing the hackathon tomorrow, meet by the Circle Drive flagpole at, 8:30 a.m.?
Yeah.
At 8:30 a.m.? Actually, I said 8:25. Meet there at 8:25 a.m. so we could be in the car by 8:30. And then we'll head up to Sheboygan. All right? I will see everybody on, Monday-ish. 1 second. Let me get this uploaded.
Yes.